All right, section 4.4. So it's our getting to our end of our days that we're going to talk about with this section. And today we're going to talk about the second fundamental theorem of calculus. So what does the second fundamental theorem of calculus tell us? Well, it tells us that the derivative from a to x, the integration from a to x of f of t dt is equal to f of x, where a is a number and x is a single variable. So what does that mean? It tells us that the derivative of the integration is equal to the value of the function at that variable. That probably seems like mud and clear as mud to you. So let's go ahead and look at an example and see what happens with this. So this is asking me to find the derivative with respect to x of the integration from 0 to from 3 to x of 2t minus 3 dt. Well, let's go ahead and pick this apart a little bit. So can we find this integration? Can I find the integration from 3 to x of 2t minus 3 dt? And I can. Our variable of integration is t, and we took the derivative with respect to t, so my variables all work out. It's just this is kind of funny to have a variable up here in our integral, in our upper bound, which we can do that. So how do we find the derivative or the integration of this? Well, the integration of this is going to be, integration of 2t is t squared minus the integration of 3 is 3t from 3 to x, isn't it? And that's just looking at this integration part. We're not worried about this derivative just yet. If I plug in my x, I get x squared minus 3x minus my lower bound, my f of 3. So I get 9 minus 9 in this case, which is 0. So I end up with x squared minus 3x. Now it's asking me to find the derivative with respect to x. So the derivative of x squared minus 3x is 2x minus 3, isn't it? Notice what did we notice? All that happened was we changed the variable. That t became the x. So any integration from 3 or any number to a variable, a constant single variable of a function, the derivative of that is going to equal that function. So can we find f prime of x given f of x equals the integration from 2 to x of t squared minus 3 dt? And this is kind of the way it's going to be rewritten as we look at our problems. Finding f prime of x given f of x equals that integration. Well, all we have to do is realize that we're going to plug in that x in for t, and we get x squared minus 3. So f prime of x is going to equal x squared minus 3. Ta-da! We're done. Not always going to be that simple, of course. So we need to go ahead and back and revisit the chain rule. And this is another version of our chain rule, which we've talked about the chain rule quite a bit. But it's kind of our chain rule that we use when we talk about the second fundamental theorem of calculus here. So dy dx. If I know du dx, and I know dy du, if I multiply these together, then I can go ahead and simplify this to just dy dx. So what does this mean? Well, the derivative of y with respect to x. If I know the derivative of y with respect to x, and I know the derivative of u with respect to x, and the derivative of y with respect to u, then if I multiply the derivative of u with respect to x to the derivative of y with respect to u, it's going to give me the derivative of y with respect to x. So it doesn't matter how many we put in this, so we can put in even a third variable. We can relate du to dx, s to u, and then y to s. So we're going to see that the du's will cancel each other out, the ds's will cancel each other out, and we're going to be left with that dy dx. Why is that important? Well, it's if we're asked to find the derivative of a function, we go from 2 to maybe something that's not a nice single variable. If this was a nice single variable, we'd be done. But it's not. So what can we do to make this a single variable? Well, we can go over here and let u equal that not such nice part. So now what do we have? We have now f of u, don't we? we have f of u is going to equal 2 to u of 2t plus 1 dt. Well, I know f prime of u then, and f prime of u, that equals dy du, doesn't it? So dy du is going to equal, well, I just plug in my u, I get 2u plus 1. But I don't want dy du, I want dy dx. So how do I get from dy du to dy dx? Well, I'd have to have a relationship between the derivative of x with respect to u. I have a relationship between u and x, don't I? So if I find the derivative of u with respect to x, that's du dx. And that's going to equal 2x. So I have my dy du. Dy du was equal to 2u plus 1. If I multiply it by du dx, so du dx is 2x, then I get dy dx. The only thing we got to do, though, is get rid of this u, because I don't want it in terms of u, I want it in terms of x. What do I know about u? U is, x squared. So I get 2x squared plus 1 times 2x. And that's going to be my derivative of this integration. That's a lot to think about. Let's look at another one then. So here we have the integration from -1 to 3x of w minus 3 dw. That's our function f of x. We want to find f prime of x. So again, we can let u equal that upper bound of 3x. Oh, we don't need that just yet. So then we have f of u. So instead of f of x's, we're going to replace those x's with u equals 3x. So we have -1 to u. And then we're doing w minus 3 dw. Our derivative, f prime of u, again, which is dy du, is equal to u minus 3. Again, remember, second fundamental theorem of calculus tells us replace that variable with this variable here, or this variable with this variable, I guess, and that'll give us the derivative. But we don't want dy du, we want dy dx. So to get from dy du, we're going to multiply or find du dx. And du dx, I started up here because I knew I had to find it. Du dx is equal to 3, isn't it? So f prime of x is going to equal my f prime of u, my dy du, times du dx. So it's going to be 3, my du dx, times u minus 3. But again, I don't want it in terms of u, I want it in terms of x. So f prime of x is going to equal, then 3x replaces my u, so I have 3 times 3x minus 3. And that's going to be my f prime of x. So, is there a shortcut to this? And those of you that are looking at this and probably a little ahead of me, you've already found that shortcut. Remember that the original derivative of an integration, we just replaced that variable with, we replaced the variable that we had in the integrand with the upper bound. So we replaced that t with x, and it gave it to us. Well, we did that, didn't we? We did it over here. We took this x squared and replaced it with that t, or that t with that x squared. So that gave us the 2x squared plus 1. And then we multiplied by the derivative of the upper bound. So the shortcut is take the upper bound, plug it in for the variable, and then multiply by the derivative of the upper bound. So we have 2u plus 2x squared plus 1. So that's what? That's our f of, think of f of x or f of u, and then times the derivative of the upper bound. D dx of the upper, if you want. All right. The last thing that we're going to talk about is what happens if they ask us for the value. And I went and scratched that out. I did have it as f prime of x, but They do like to find the value, the derivative, at a x value. So we got to be able to do that as well, given that the function is the integration from something to something of a function. So again, we have our u, which is the sine of x. So that's our upper bound there, sine of x. I know I need my du dx, just like I did before. I know I need that, so derivative of sine is cosine of x, isn't it? So my derivative, f prime of x, is going to equal the cosine of, I'm going to plug in my sine of x, so sine of x, times the derivative of the function, cosine of x. I now can go ahead and find f prime of whatever value I want. So f prime of pi over 2. So I have now the cosine of the sine of pi over 2 times the cosine of pi over 2. I know the sine of pi over 2, if I remember my unit circle, of course we do, is 1. And then the cosine of pi over 2, oh, I didn't need that. Cosine of pi over 2 I know is 0. 0 times the cosine of 1 is going to be 0, isn't it? So that gives you kind of an idea of where we're going to see this and what we're going to actually do with it. So, second fundamental theorem of calculus tells us that the derivative of the integration from a constant to a variable is equal to f of that variable. And if it's a not nice, clean number or variable, so if it's just not a single variable, we got to take and plug that x squared or that variable in for our variable that we're given in our integrand times the derivative of the upper bound. So if you have questions, please let me know. Good luck, enjoy, happy integrating.